This is AWR Microwave Office tutorial series. In this video, we will talk about VSWR or Voltage Standing Wave Ratio and its simulation using AWR Microwave Office. So let's get started. In the first step of this video, we are going to open previously created project which you can download using the link given in the description. Once it is downloaded, you can open AWR Design Environment 22.1. To open the project, we'll go to File, Open Project. Just locate the file which you have downloaded. In my case, it is saved in this AWR folder. Select the mismatch transmission line.emp file and click over Open. Let's go back to the schematic. Now once the project has been opened, next we are going to create a new graph. To do that, we'll go to again Project Window. Here we'll go to Graphs option, right click and click over New Graph. Here let it be like graph 2 and make sure you have selected rectangular and click over Create button. Once the new graph has been created, we are going to add new measurements. To do that, we'll just right click over Graph window, go to Add New Measurements, and here make sure you have selected Linear Measurements type, and in the measurements you'll find VSWR. So just select that, choose the source of the schematic. So in our case, it is mismatched transmission line 1. Port index should be 1. Frequency sweep will be on the x-axis. Now click over Add and close it. So we have added the mismatched transmission line and we are going to calculate the VSWR for that. Now before hitting the simulation button, we are going to discuss a bit about the schematic. So as you can see in the schematic, we have 50 ohm source which is coming from port 1. Then we have this 50 ohm transmission line. Length is variable, which we will see what is the effect of length on VSWR value, and then we have terminated it to 25 ohm. So here we have a clear mismatch. It should be 50 ohm. We'll let it be like that because we'll see VSWR value because of standing waves due to this mismatch. Now what will be the expected value of VSWR? So if you remember, VSWR we can calculate it's a 1 plus reflection coefficient divided by 1 minus reflection coefficient. Alright, and reflection coefficient in this case will be 50 minus 25 divided by 50 plus 25. If you calculate that, it will be 0.33. Alright, and then we'll just put that value in VSWR formula. Then it will be 1 plus 0.33 divided by 1 minus 0.33. And when you will calculate that, it will be approximately 2. So as per our simulation or as per this mismatch circuit, the value of VSWR should be 2. Let's run the simulation now. And let's close this window. Alright, so here we can see since the frequency is fixed, at this frequency, we are getting the VSWR value 2 here. Now we'll see what will happen to VSWR value when we change the length of a transmission line. So we'll just open the tune since we have already selected the tunable parameter. Alright, so here we are varying the length from 0 to 100 mm and we can clearly see there is no effect of length in VSWR. Alright, because it is happening because of mismatch. Similarly, if we'll tune the other parameter, which is let's say the termination register. So to do that, we'll just select the tune tool, select the value of R, go back to tuner, and we are going to change its value from let's say 25 to 50 or 75. Let's make it 75. So we can see like what is happening if we are increasing the impedance. So it's like upper side of mismatch. All right. Let's go back to graph 2 and at 25 the value is pretty much same. So as you can see, as we are increasing the value of VSWR up to 50 ohm, it is going down. Alright. Now if we are increasing the value above than 50 ohm, then it's again increasing again. So why this is happening? Why the value of VSWR is going down when we are increasing the impedance, and when we cross the matched transmission line, that means after 50 ohm, why it is increasing again? Alright, so to understand that, we have to look at this standing wave pattern of the transmission line mismatch. All right. So as you can see in this picture, as we are moving the tuner, you can see we are getting the Vmax. So VSWR is nothing, it is just ratio of Vmax of standing wave divided by Vmin of standing wave, right? So as we are moving further or changing the impedance value, you can see we are moving on this standing wave. So we can clearly see why this is happening. This is happening because of this standing wave pattern. So that's it for this video. I hope you understood the concept of VSWR and how we can simulate that in AWR design environment. In the next step, we are just going to save the project. So first let's close this tuner. We'll go to File and click over Save Project. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.